In the final section of this problem, we're going to ensure that the uncertainty principle is satisfied with the answers that we determined. We're going to begin with the uncertainty in the position, which we can go ahead and write as the difference between the expectation value of the position squared and the square of the expectation value. Now, this is going to be relatively easy since this term right here was found to be 0. Well, actually, this term right here was found to be 0 in the earlier part of the problem. If you're a little confused on that, you can go ahead and look back at the earlier videos for this problem. But now I'm going to go ahead and substitute in for the expectation value of the position squared, which was found to be this value here. Now these values kind of make sense in terms of units and everything, but we want to make sure that they make sense in terms of the axioms that we know from quantum mechanics, like the uncertainty principle. So that was the uncertainty in the expectation value, the uncertainty in the position. Now we're going to move on to the uncertainty in the momentum. And again, this value right here was found to be 0. And we can go ahead and substitute in for the momentum squared expectation value. All right, looking pretty good so far. Now we're going to move on to the final step, which is making sure that the product of these two are actually greater than or equal to the ratio of the h bar over 2 to 2. So we'll go ahead and throw these in. And I'm going to go ahead and throw these two terms. So this term here and this term here, right here and right here. I'm going to go ahead and throw them under the same roof, the square root. They like to hang out together. They're pretty good friends. So we'll go ahead and just take care of some bookkeeping. Oops, not that one. That's really important. The mass terms and the angular frequency terms, the omegas, go away. And we'll go ahead and identify the squares, which are right here. So an h bar will come out. H bar is going to come out of the house of the square root with its friend, as well as some 2's, technically some 1/2's. And finally, these are both squared values under the same roof. So the square root goes away, and all that's left with is this. And as we can see, we have an h bar here. And since n is going to be either 0 or greater than 0, as you can see, that this is always going to be some term that's at least greater than 1. So that verifies that this is actually always either equal to or greater than h bar over 2. And it satisfies the uncertainty principle.